it does let go, which I can switch on, or I can also start dimming it down. And so I'll put a hand in here, maximum of 3 kilowatts. Let's get familiar with the RGBW dimmer. Now I have a few devices connected to it, which we're going to reveal in a bit, but first of all, let's focus on the device itself and see what kind of features, what kind of connections we need to the device. Now I'm going to be using my handy multimeter in here, and we're going to first of all check what is the power supply required to the device. Now the RGBW dimmer can work with both 12 and 24 volts and a few voltages in between. Now you can see the red and black cable, which would, if you were to check in here, you can see there's 24.2 volts stable going into the device and supplying it power. Now, just next to it, as you can probably guess, you have the green and white wire, which is your tree communication, which is basically telling the device what it needs to do and at what time. Now, on the top of the device, you have RGBW, and then you have the positive going out. So the positive going on top and the positive going on bottom, they are actually linked. And if you were to ever look at the PCB, you'll be able to see that there's continuity. They're basically linked. So if you were to grab the positive from here or here, you wouldn't necessarily make a difference. What makes a difference are the negatives. And this is where the control is really happening, because it is a PWM device, which means that it's basically switching off the device for a period of time. Every single time it tries to modulate something on the other side. How to really utilize it is a question. Now, the first things first, as you can see on the mini server, I'm using the very first relay, and that first relay is being used with just a 24 volt Maglock, probably world's smallest Maglock. That is just an example of something that is controlled on and off, and it's also a 12 or 24 volt relay. Now, if I was to run out of relays on the mini server and I do need to control an on-off device, a 12 or 24 volt device for that matter, on and off, then I can use a spare relay or a spare channel on the RGBW dimmer itself. You can see the relay itself. There's a door lock release. So if I go and press it in the app, it does let go. I switch it back on and it goes back in place. Now, a completely different example, different topic, but also in here on the top, I do have a mechanical override, which would be very similar to like a break glass situation. So if I was going to press this, it also cuts the power, even though in here in config, the door release is still on. So if I was to switch it back on, I can put it in place if I want to, and again, break the connection as a mechanical override. From here on, everything else is going to be on the RGBW itself. So I'm going to be, first of all, showing the simplest thing and what most people use it for, which is individual white channels. Now you can use that with LED strips, which is probably the most common use case for people that want tunable white or just warm white. It is possible to use it. You don't always have to use RGBW. And in my example, I do have a lighting controller in here, which I can switch on, or of course, because it is proportional control, I can modulate it from 100% brightness all the way down to, well, basically as low as it really goes. This is probably going to be the most common example and the one that you're familiar with. This is also the one that is very well documented. So you can use either just white, or you can also use tunable white. So obviously being able to adjust color temperature. But the next step up is going to be LEDs. Now we do have a 24 volt bulb in here. Now that bulb is dimmable, so I can switch it on to bright if I want to. I can also start dimming it down. And right now, instead of me having main dimmable lighting and using a whole dimmer, I can just use a single channel on the RGBW dimmer, and I can have quite a few lights on it because these are very low consumption LEDs. A few of the better examples is this one here. Now this is a lock or a release, and as soon as basically power is provided for a very short period of time, it's a very short burst that I'm going to show you, this is going to be released, and if it's attached to obviously some kind of a door, it's going to release it, it's going to push it, and you can have access to your cupboard, for example, or anything else that's behind it. Now in config, I have made it just as a little push button, and keep in mind it does get ejected quite violently. So I'll put a hand in here and it's gone. last but not least is going to be the solid state relay that we have in here. First thing first, disclaimer, please do not use this solid state relay in particular. These are very cheap and they do tend to melt if you go and look in forums. However, how can that really help you and how can that work if you were to buy a better quality solid state relay? Now, on a single channel of the RGBW Dimmer itself, you can connect to the DC side of a solid state relay. If it's obviously DC to AC or DC to DC, you have different options. But in this case, this is a DC to AC solid state relay. And with a solid state relay, what you can do is you can control and modulate a resistive type of load. A very common example is a heating rod, or better well known as an immersion heater, as a heating element, as a boost in your house. Because, for example, if you were to have solar and you have a lot of excess solar generation at the moment, instead of selling it back to the grid for pennies on the pound, pennies on the dollar, how everyone said, you are going to be able to say proportionally, instead of using 3 kilowatts at the moment, I can only use 250 watts or 500 watts or 750 watts. And you can see it by the little indicator that a solid state relay is doing something. And if I was to have an immersion heater or the load of the immersion heater connected on the other side, I would have been able to control it all the way down to, let's say, 50 to 100 watts and all the way up to its full potential, which is going to be the maximum of 3 kilowatts. Now that we know that and we have seen it in action, let's go in config and see how we're actually going to configure it and how you're going to be able to split the channels and set them up correctly. So in config, there are quite a few things that we do need to consider. The main thing is going to be the actuator type, so let's look into it. If you were to go to your RGBW Dimmer that you already have in config, click on the gear knob, that is going to open the properties, and in the properties you have this one, which is called actuator type. Now with actuator type, you see that there's a few different options: smart, standard, individual channels versus tunable channels. Now, when it comes to smart tunable, I'm not really going to cover them, but standard and smart, I just want to give you a general overview. Now, when it comes to smart, smart is what the device is set by default, and that simply means that if I was to grab a lighting controller, let's grab this one, drag the device, drop it on top, I can already use it. Obviously, if I was to have just an RGBW strip, that is it. That's the easiest way to do it. But also, another thing, if you have it on smart, that means that the lighting controller itself is going to be deciding the on and off, fading in and fading out times. So basically, whenever you have your lights off and you press them to go to, let's say, 80% or 100%, it's going to take maybe a second, or it's going to take half a second or whatever period of time for them to go from 0 all the way to 100, and you can see them gradually fading in and fading out. If they were set to smart, the lighting controller is actually going to be the one that decides how long does that take for them to fade in and fade out. If you were to change that and set them to standard, you see that two things are going to change. First off, you're going to have RGB and W as two separate channels that you can again still drag and drop connect in here. But now that is also going to give you the option on every single individual one of them to change the fade rate from 100% to 50% and so on. And you have another value in here, which is perception correction, which is basically what your eyes perceive versus the actual values. Not important at all. But what you can do, and what is a nice hint in here, is if you ever tried to have white and also kind of simulate white from the RGBW at the same time, you can do it from here. So you can max out the white in here, and you can also get a little bit of white from the other ones. Now, enough hacks. Let's look at the better use cases. So when it comes to smart tunable whites and individual channels, or just smart tunable white, you do have that example in here basically. So if you were to use just an LED strip, a tunable white LED strip, you can use two separate tunable white LED strips individually, maybe in two different rooms or two different areas that you want to control. Or you can use a tunable white plus two just standard warm white LEDs, completely up to you. You can mix and match basically. Now, the important ones and the interesting ones are actually these, which are smart individual and standard individual. Now, to explain the difference, I have made basically a little presentation, and smart individual is the first one I want to look into. because if you were to have just lights, you can have a single channel of lights being controlled. You can connect all your lights, and the only limitation in here is basically the amps per channel. And at 24 volts, at 24 volts, that is going to be 50 watts, and at 12 volts, that's going to be obviously 25 watts, so half of that. Now, with this configuration, you can still use the smart functionality of fading in, fading out from the lighting controller, and all you really need is just a single channel to control quite a few lights. Now, in my example in here, I do have 6-watt bulbs, so if I was to have 3 of them, that is 18 watts, that is barely scratching the surface. So as you can imagine, I can do a whole room, like a whole proper circuit with just a single channel on the RGBW. And because I have another 3 channels to spare, I can basically do another 3 rooms with just 12 or 24 volt bulbs, or obviously LED strips, exactly the same way. Now, the better way of using it is not going to be the smart channels, but it's going to be standard channels, because with standard channels, you might be controlling other devices that are not necessarily being dimmed, and then the fading completely does not matter in that instance. So if you were to look at this configuration in here, you're going to have your positive and ground connected. Now the positive is going to be shared across all devices, but now the RGBW, or the negative channels, are the ones that are controlling individually every single device. And now in here, what we do have is we have the red, or channel 1, going to the lock, the green, or channel 2, going to the solid state relay, and the blue, channel 3, going to the Maglock for this example. Of course, you can do any other devices, you can mix and match in here. I do have an available channel that can potentially go for an LED strip or any other 12 or 24 volt device that is on and off, in this case 24 ideally. But that is the important thing to note. The positives are all shared, you use the same positive. The negatives are actually the ones that are going back and are giving you that individual control, and either on and off or modulating up and down. And the last thing to note in this end is that it really doesn't matter which RGBW dimmer you go with. You can use an RGBW tree or RGBW tree compact, RGBW air or RGBW air compact. They all do pretty much exactly the same thing, because the limitation of the channels is the same. The only thing that really changes is the form factor. So whether or not they go in the panel or they go nearby the installation location, or whether you communicate via tree or air, and that's it. So in config, let's actually do that. Again, if you go to your RGBW dimmer, you click on the gear knob, you go to actuator type, and we want to change it to standard individual channels in my case, because I have devices that are not necessarily lights. And as soon as I change it, you see dimmer 1, dimmer 2, 3, and 4 already in here. And these also correspond to RGBW in the same order. So if you were to double check on the device, you are always welcome to do it in here. So channel 1 is red, channel 2 is green, and so on and so forth. Now, because I have quite a few different devices, I do have a little cheat sheet for me where I've just named them, and I'm going to show them one at a time. So for me, channel 1, the red, is actually my 24 volts bulb. It's an E27 bulb, but that does not necessarily matter. That's only for us. And all we really need to do to control it, put it on the lighting controller, drop it in here, job done. And this, for example, can be the lights in a, I don't know, living room, for example. Then I'm going to show you the other easy one. On channel number 4, I actually have that LED strip, that single LED. So I have just a warm white LED strip in there, a very, very short piece, so I don't need to give any specific information for it. And that can either be in the same room if I want it to be. Maybe this is just a different lighting circuit, or this can be in the bathroom, for example. Now the lights are going to be the easiest ones. You don't really need to think about much. They do act the way that they're supposed to. They dim up and down. That's it. You have full control. But the other channels that do matter, in my case in here specifically, is the solid state relay and the 12 volt lock. Now I'm going to start with a 12-volt lock because it's an interesting one. Now with a 12-volt lock, there is quite a few for us to consider. Now, first of all, this is going to be 12 volts lock or 12-volt release, whatever you want to call it. But you'll be able to see that in here, there are quite a few settings that are not necessarily important or actually going to be harmful to the device itself. So first of all, my 12-volt lock has only two states. It has an on and an off. That's it. I don't care about dimming. I don't care about it fluctuating from 0 to 100%. I just want to see either 0 or 100%, nothing in between. So what I'm going to do is I'm going to remove this tick box, which is perception correction. The fade rate, I don't need it to fade, so I can basically tell it to jump, which means that as soon as you give it a value, it's going to directly go to that value and it's not going to skim in between. And now I can adjust my inputs in here as well. So every single time that I see 1, I'm going to say to the solid state relay or to the channel, go to 100%. And every single time I see a 0, it's going to be a 0. So that way I'm just simply mapping 0 and 1 to 1 and 100. And I'm basically sending 100% to that channel in particular. Now I'm not going to use a switch, I'm going to use a push switch. Or actually a push button might be better, because in the manual of this specific device, it does say, I'm going to put a hint text in here, that you shouldn't, oh well, I basically say do not power the lock for more than 0.2 seconds, because you can burn the motor. These are quite cheap and fragile, easy to break. So a little hint text from me in here would assure me that every single time I configure it to do anything, I'll make sure that if I'm sending a pulse, I'm sending a very short pulse only. And I can adjust that pulse from the push block to 0.2 seconds in here. And now this is going to be my 12-volt lock release, or whatever else I want to call it. So now if I was to go and press it, I don't know if you're going to be able to see it because obviously it's happening quite quickly. But the value in here is going to be mapped from 0 to 100. And I'll just save this in actually. I'll go to the app. Let's look at the rooms, test. And it's 0.2 seconds, so don't blink. It's happening very, very quickly. I think you can also hear the lock behind me if the mic is not muting it. But what is happening is very, very quickly. It's sending a signal and it's saying I'm seeing 1 or 0. And that 1 is getting automatically converted to 100. There you go. And the lock is triggering every single time. Cool. Last but not least is going to be the immersion solid state relay. I'll drop it in the page. And first of all, let's focus on the control part. I already have one, but I'm going to create another one. Not a text one. I'll just create a virtual input so I can have a slider in the app to tell it where it needs to go to. But this is going to be my slider. And this is going to be immersion proportional control. Not great naming convention, not very customer friendly. But if I click on the gear knob, I'll be able to basically set it in here as an input type. Well, it does not need to be digital, it's going to be analog. I'm going to have a minimum value of 0, because obviously we can go all the way down to 0 kilowatts, and the maximum value of 3, because most immersions again are going to be 0 to 3 kilowatts. I'm going to change this up to maybe .2, and I'm going to call it kilowatts. And my outputs are going to be, well, whatever the device is. So minimum 3, maximum 3, minimum 0. I'll connect it in here. And we now also need to set this with the right correction values as well. Now, once again, I don't care about fade rates and corrections. So I'm going to remove this and I'm going to make it jump. So it's going to immediately go to whatever value I give it. It's not going to try to fade into that place. Now on this side, you can probably already imagine what's happening, but this is my mapping. So whenever I send a 0, I want to see 0, so 0 kilowatts being sent. And whenever I want 3 kilowatts, I want the output to go to 100%, which will then go to 100% on the solid state relay, which will then demand 100% of the immersion element itself. And the immersion element, because it's 3 kilowatts, would obviously reflect accordingly in this case. So long story short, I'll save this in. I don't know if we've put this in the app. We have not. So let's tick the, oh no, it is already in there. Great. So you can see now the correction values are going to make a bit more sense now, because if I go to my test city again, go to the immersion, I go to 1 kilowatt, and that 1 kilowatt is now getting converted to 33% of the total load on the channel. I go to 2 kilowatts, 67%, and as soon as I go to 3 kilowatts, the 3 kilowatts are getting mapped to 100% demand on that channel and on that immersion itself. If I do want to have a better or more gradual control, I can change my step size to go to, let's say, 0.2. So I'm going to be able to change it by 200 watts every single time. We'll wait for this to load up, go back to test city, and now you can see that every single time I move down, it's mapping the value that I have to the correct percentage of the output, and as soon as I connect the immersion element, it's going to proportionally control it straight away. And believe it or not, that is pretty much all that I want to show you today. And the most important part for me is really your stories, because I know that quite a few of you have used an RGBW dimmer in very, very unique ways, and I'm very interested to hear about it. So please leave a comment down below and let me know what is the coolest thing that you've done with an RGBW dimmer, because I'm pretty sure there's some crazy people out there that have geeked out at 110% and have done some ridiculous things with the RGBW dimmers. So I'd love to see it, I'd love to hear about it, so do let me know. See you next time with another video. Hopefully this time is not going to take 7 months to get to it. So bye guys, and see you soon.